right, so we're going to do some warm-ups to get ready for the 6-5 quiz here. So I want to try a few of these. I really want you to try the question first. So pause the video for each one of these, give it a try, and then come back and check the solution just to make sure you're really feeling like you're able to deal with what's happening here. So try each of these, pause the video one at a time, kind of check your work as you go, or you can try all of them and then watch it at the end. But make sure we're using the zero product property or zero factor property to help us solve for solutions for these quadratic or degree 2 equations. All right, so for the first one, we always want to double check and make sure that it's equal to 0 first. So it is equal to 0. That means I can use that zero factor property. And it's actually already factored, so even better. That means I can just take each of my factors and set them equal to 0 and solve. So I'm just going to set each of these equal to 0 to find out what values of x make each of these true. So the first one, I'm going to subtract 7 on each side, then divide by 8, so negative 7/8. And then the second one, add 21 on each side, and then divide by 3. So I actually end up with two solutions, either x equals negative 7/8 or x equals positive 7. So I have two solutions in that zero product property. All right, so let's take a look at the next one. Again, pause the video, try each one as we go to make sure you're okay. So first order business, is it equal to 0? Yes. So that means I'm ready to start factoring. Take a look, are there any GCFs to pull out? Well, no, it's not factored yet, but there's no GCFs, no common factors. So we're going to go right to two binomials, and we're going to see if we can factor this. So x squared comes from x times x, and now we need numbers that multiply to 30 that add to negative 11. So think of things that multiply to 30 that add to negative 11. Okay, now first of all, if they multiply to a positive and add to a negative, remember if they multiply to a positive, the signs have to be the same. Since they're adding to a negative, they both have to be negative. Okay, so think of the things that multiply to 30. So make your list and then see which of those pairs adds up to 11. Well, it's got to be the 5 and the 6, right? So multiplies to a 30, adds to 11. All right, so once you have it factored, set each of your factors equal to 0 and solve. All right, so what makes each of those 0? We'd have x equals positive 5 or x equals positive 6. So I get two possible solutions. Those are the places where it crosses the x-axis, or that parabola crosses the x-axis. Those zeros are the function. So zero product property, make sure it's equal to 0 first and then factor. All right, so take a look at number 3, same process. Pause the video, see if you can do it, and then come back and check in on the solutions. All right, so does it equal 0? Oh, no, it doesn't. So that means the very first thing you need to do is get those terms on the same side. So I'm going to go ahead and move that 11x over. So 121x squared minus 11x equals 0. We're always moving terms from one side of the equation to the other to get that to be equal to 0. So got to get it equal to 0. Next order of business, there's only two terms here, so it looks a little different than those trinomials. It's definitely not factored. Remember how we always look for a GCF first? So is there a GCF? What could you pull out of both? Well, there's an 11 and a 121. Doesn't 11 divide into 121? Sure does, 11 times. So 11 is in common, and notice they also each have an x. So we're going to pull out a GCF of 11x. All right, what's left inside when we do that? All right, so 11x times what would give me 121x squared? Well, that would be 11x, perfect square, so 11 times 11, minus, this is the tricky one that people forget, 11x times what would give me 11x? So 11x times what? Well, to get the same number back, remember you have to multiply by what? 1. Don't forget that placeholder, though. If we do, we're going to lose a solution. We can't just say 0, because if it was 0, then there wouldn't be any term there at all. So just be careful. If you pull out the common factor as your term, it's times 1. All right, now we can set each of those factors equal to 0. Now, what's weird for people is this 11x is a factor. That's the first part of the product. There's only just a monomial there. And then times a binomial. So the other one would be 11x minus 1 equals 0. And we solve these two for x. All right, well, the first one, how do you get rid of multiplying by 11? Well, you divide by 11. So x equals, now this is the part that if you're not sure, type it in your calculator. 0 divided by a number, that's 0. So 0 is one of your factors, one of your zeros. The other one is add 1. So we've got 11x equals 1, and then divide by 11. So this other one's not such a fun number, 1/11. So it's going to be a fraction. So one of my solutions is 0, and the other one is 1/11. So lots of things to consider on this one. It wasn't equal to 0, so move the terms over. We had to do a GCF. There was no way to factor it otherwise. Don't forget about looking for that GCF. All right, we got two more to try here. So we're going to hit kind of the same kind of format, thinking about the same sort of things. So pause and see what can happen. I know there's no 4. We're skipping the number 4. We took that out. So we are going on to 5. All right, so first order of business, is it equal to 0? No. So we need to get it equal to 0 first. So I'm going to add the 11x, and I'm going to add a 5. So I'm going to add both of these terms, and you can do it all at once. And let's put our terms in descending order. So 2x squared plus 11x plus 5 equals 0. So get everything on one side. Now, why did I move that way? Well, the 2x squared was positive already, and it was on the left. So for me, visually, that's the easiest. But you can go either direction. I just think it's easier, even though we had to move 2 terms, to make that first term positive. So make it equal to 0. Check. Next thing, check for a GCF. A 2, an 11, and a 5. Out of luck. All right, 3 terms, so a trinomial factors into 2 binomials. We're going to have to do a little guessing and checking here. That leading coefficient's a 2. So remember, this is the product of the first. How do I get a 2x squared? Well, that would be a 2x times an x. From the last, how do I get a positive 5? Well, now we're in luck. It's a prime number. Positive 5, there's only one pair that multiplies to 5, and that's 1 times 5. So we just have to figure out where they're going to go. Everything's positive, which means our signs are all plus. We need to make an 11. So think about doing your outsides plus your insides. If we have to get to an 11, don't we need the 5 out here? 2 times 5, that would give you the 10x. And then the 1 here, 1 times x and 1x. And sure enough, that would give us that 11 in the middle. So think about what you're trying to make, and that I think helps. All right, so we have our factors. So we're going to set each of those factors equal to 0, and we're going to solve. So the faster we can factor, the quicker we're going to be able to solve for x. All right, so we're going to go ahead and solve each of those for x. So subtract 1 and divide by 2. And then this one's just subtract 5. So we get 2 possible solutions, either x equals negative 5 or x equals negative 1/2. So we got 2 solutions that are true. All right, last one. For this one, when you take a look at this, again, think through our checklist. So we're going to start with, does it equal to 0? Yes, it does. And remember, you should be pausing the video, try it, and then come back. So it definitely equals 0. Next thing we check for is that GCF idea. Is there anything that you can pull out? Looks like we got a 4 and a 16, so I can pull out a 4. And not only a 4, I could actually pull out a negative 4. Now, the reason I would do that is because I kind of like to factor with positive terms. So if you think about pulling out the negative 4 times what gives you negative 4x squared, it would just be the x squared. Get that negative sign on the outside in the coefficient so you don't have to worry about it when you factor. All right, now careful here. Negative 4 times what would give you a positive 16? A negative times a negative would give you a positive 16, and 4 times 4. So just be aware of that sign. Otherwise, you're not going to be able to factor further. This brings up one of those awesome situations we did before. 2 terms only. That's one of those difference of squares. That's where when you factor, the 2 binomials are identical except for the sign in between. So it's a difference of squares. That was the one that was like x squared minus y squared is x minus y, x plus y. So they're the same binomial, just opposite signs. Both of these are something squared, right? An x and a 4 are both perfect squares. So when I do my factoring, what do I multiply to get x squared? Well, x times x. What do you multiply to get a 4? Well, if it's a perfect square, it's 2 times 2. And then to get a negative, there's only one way that can happen, a positive and a negative. So difference of squares is a great thing to continue to look for, because now I can use my zero product property. So here are 2 factors that have variables in them. So I'm going to set those 2 factors equal to 0 and solve. Now you might be asking, what about the negative 4? It's not a variable term. It doesn't have a variable with it, which means it doesn't factor, pun intended, into your solutions at all, because there's no letter with it. It's just a numerical coefficient. Doesn't matter. It's like how steep that equation is going to be, but it still crosses the x-axis in the same spots, which are going to be these 2. So the only factors you consider are the ones with variables, because those are the values you're solving for, the x's. So either x equals negative 2 or x equals positive 2. So don't worry about those numerical coefficients. Only the variable factors will give us our solutions for what those values of x are. So looking for things like difference of squares, GCF, really important. And also just make sure your equation always has to be equal to 0 first.